Hey everybody, today we're going to start up back into the first session of the spring 2019 MCAS, so let me go back to the page here. So, yep, 2019 spring session 1, so we started this before. What we're going to do is continue, we'll probably do, well, at least 3 or 4 problems. And yeah, what you should do, if you haven't done so already, is click on the link in the description, the video description. It brings you to the website in which you can do this digitally. Try the problem. If you don't have a copy of the PDF, or if you're not one of my students, print up the PDF, and then after you try the problem, go to the end of the test. You can click the review button, choose the end of the test, see if you got the answer right or not, and then watch the video. So if you have not done the problem yet, try it on your own digitally in the link, and then watch this part. So that's how this is supposed to work, okay? And that way you'll finish this up eventually, and you'll be ready to rock with this MCAS, okay? So let's get right into it. Number 4, on a coordinate plane, a single transformation will be performed on square RSTU. Okay, so it's a single transformation, all right. Select 3 transformations of square RSTU that would result in a congruent image, a congruent figure. So we're looking for rigid transformations. We're looking for transformations that preserve congruency, right? The 3 that come to mind are translation, right? That's a shift. Let me zoom in a little bit more here. The other one would be, let's say, rotation, and that is a twist. And then we have a reflection, and that is a flip. So we have dilations, but dilations do not necessarily preserve congruency. They preserve similarity, which is different, right? Congruent means they're the same shape, same size. All right, so let's see which of these would preserve congruency, and we're looking for 3 of them. So that means we have 5 options. 2 are not going to preserve congruency. A dilation by a scale factor. I want to start at the bottom, actually. A dilation by a scale factor of -2 with respect to the origin. So this is actually resulting in a shape that is twice an image that is twice the size of the pre-image. So this is out. That is not going to preserve congruency. Same thing here. It's going to be 1.5. So no, that's not going to preserve congruency. If you multiply by a scale factor of 1, you actually do not change the size. So that would work. A rotation. Rotations do preserve congruency. That would work. And a translation, that's a shift, that would work as well, because it's not changing the actual size of it. So it would be A, B, and C. Okay? Number 5. Okay, so system of equations. All right, so they're asking us to consider this. We have 2 equations here of h plus c equals 2.25, and h minus c is 1.75. What value of h makes the system of equations true? H is what? So there's a few ways to solve this. You could plug numbers in until you get the right answer, which would take forever. I would not recommend that. Instead, we're just going to use elimination. So there's generally 3 ways of solving a system. There's graphing, there's elimination, and there's substitution. Let's zoom in a little more. Actually, yeah, I have to write a little bigger, I guess. Right. There's no graph, so that's out. I mean, you could sketch it, but I wouldn't recommend that. You could substitute, but it's way easier to eliminate these. Okay, so we're basically going to squish these 2 equations together, and that'll isolate the h, and it's actually set up for us to do that. So check this out. Let's combine these together. What's h plus h? 2h. What's c minus c? 0. Let's add these together. So this would be, a quarter and 3/4 is $1, so 4 right there. 2h equals 4. Let me write that down here. Let's divide by our coefficient, which is 2. And h equals 2. And that's it. That problem, in my opinion, is significantly easier than it could have been. So I hope the MCAS has a problem like this, because if we're comfortable with systems, this problem should be a cakewalk for us, as long as we're comfortable with systems, right? All right, number 6. Now this one looks tricky, but it really isn't. There's a trick to this one, all right? So here we go. Which of the following is equivalent to this expression? Now when you first look at this, you might say to yourself, oh, I gotta remember how to factor, right? Factoring seems to be what they want me to do here, right? But it's actually, in my opinion, it's significantly easier just to distribute these options and see which one ends up with our preliminary set of terms here with our trinomial. You can factor this, don't get me wrong. If you're comfortable with factoring this and just being able to identify the greatest common factor with all three of these terms, then feel free to do that. And I'll go through that in a minute. But in my opinion, it is way easier just to distribute these because most of us are, by this point, have done a lot of distribution. So again, let's start at the bottom here. So let's just distribute. We're going to distribute all these and see which one ends up here. And that's how we're going to do it. Again, I did mention this at the top. You really need to be using scrap paper. So the test is on a computer, but use the piece of scrap paper you have to write this down. And if you're transcribing, like this part, you'd have to rewrite it. Make sure you're writing it correctly. Be very careful if you're rewriting it that you don't make a mistake going from the computer to your paper, okay? So let's go ahead and distribute this. So 2k squared times 2k squared would be 4k to the fourth because we have to add those exponents. Plus 2 times 16 is 32. K squared times k is k to the third because we have to add those exponents. So 2 plus 1 is 3. And then 2 times 10 is 20. And bring the k squared. So it's not that one. Okay. Let's try C here. So we distribute this 2. So 2 times 2k, so 2 times 2 is 4. We still have a k to the fourth. Okay. 2 times 14 is 28. And still have k to the third. And 2 times 8 is 16. And we have k squared. It's not that one. Let's try this one. Distribute the 2k squared. Okay. So 2 times 2 is 4. K squared times k squared is k to the fourth. 2 times 8 is 16. K squared times k is k to the third. And 2 times 5 is 10. Bring the k squared. You'll notice all these are positive because there's no other mixed signs here, so you don't have to worry about mixed signs. This is looking like the answer. Let's just try this last one, make sure you make a mistake. So k squared times 4 times 1 is 4, and then k squared times k squared is k to the fourth because we're adding the exponents. 4 times 4 is 16, and k squared times k is k to the third, and 4 times 2 is 8, and bring the k squared. So this one's close to it, but it's not quite. So that's our answer. Okay. So if you just distribute it, which we can all do, you'll do it. It takes a little longer, but that's okay. I think it's an easier way to solve it. Now, let's say you wanted to factor it. You just have to look to what number divides all these, right? So what's the largest number that divides 4, 16, and 10? Well, it's 2, right? And we know they all have a k in common. Well, what's the lowest exponent? It's 2. And then you just divide all these by that. So you're going to end up with 4 divided by 2 is 2. And k to the fourth divided by k to the second is k to the second. So you can see this is, I'm probably going to run out of room here. Let's see. 16 divided by 2 is 8. And then we're going to have k left. And then 10 divided by 2 is 5. Yeah, see, it's going to look weird. And that's it. So we end up with this. But honestly, I think most of us, like 99% of us taking this test, are going to be better off just distributing it. Okay? All right. Let's do one more. Let's do one more. Now this one, I gotta bring up the computer screen on this one because I know this is one that's a little weird the way you put the answer in here. This is number 7. Okay, so the way this is going to work and the way you solve this on the computer, it can be a little confusing. So first you need to select whether or not, well, they're asking us to graph this inequality, okay, graph the solution to this inequality. The first thing you need to know is that this is a greater than or equal to sign. So this is saying y is greater than or equal to x minus 4. So I'm just going to rewrite this on the other sheet here. So I'm going to write that here. I couldn't get them to both print on the same without looking weird. So this is what we're going to graph. Okay. All right. Now, first things first, we have to just determine what the y-intercept is. So we're still going to use our linear equation formula, y equals mx plus b. Okay. Our b is negative 4, so we're going to plot a point here. Make sure I'm on camera here. Yep, here we go. So negative 4 is right here. And our rate of change is the number in front of the x, which is 1. So we're going up 1 over 1. Okay, that's what it's going to look like. Just like that. And then down 1, left 1. Okay. So we have to determine, one second, let's see, pause this. Okay, so we have graphed these points. We have a rate of change of 1, right? I'm going to zoom in a little more here. Okay. now we need to decide whether or not it is a solid or dotted line. Because this is or equal to, this is considered to be inclusive, okay, for all you interval notation fans out there. This would be with a bracket, right? So because it's inclusive, that means the line is part of the solution. So we're going to draw a solid line. I don't have a ruler, so forgive me for this not being like very great. That's our line. It's kind of a line, right? Not that bad. But now we have to decide what region to shade. So you're going to click this button after you chose the line and graph these points. And the 2 points, by the way, you can't just go up one over one. You have to be outside of a little radius they have. It's kind of annoying. So you go up 2 over 2, it's fine, and it'll create the line for you. The way you graph this, you have to plot 2 points. So now we're going to decide which region to shade. So I'm going to use a test point. I'm going to use this as my test point. Okay, I'm going to plug in those coordinates, which are 0, 0. So I'm going to put in 0 for x and 0 for y, because that's the coordinates at that point. So I'm going to do y is greater than or equal to x minus 4. 0 is greater than or equal to 0 minus 4. 0 is greater than or equal to negative 4. So this is a true statement, which means this is part of the solution, okay? So it means I'm going to shade on that side of the line. So you would simply click region and then click on that side, and it'll shade it for you. And that is it for that one, I think. Yeah, so let's stop there. I haven't done this one yet, so, well, can we do this one? No, let's do this one later. Okay, so, no, you know what? Let's do that one now, because the next one's a multi-part problem, so let's just do this one right now, actually. So this is number, is this 8? Yeah, there's 7, this is 8, okay. Okay, here we go. So line W is represented by this equation. Which of the following equations represents a line that is perpendicular to line W? So this requires you to understand a few things. One, the linear equation y equals mx plus b, like how to use that, how to identify the rate of change. And what does it mean when a line is perpendicular to another line? So perpendicular is all about rate of change. Okay, so our rate of change here is 5, because y equals mx plus b. So the rate of change or slope of this line is 5. A line that is perpendicular would be the reciprocal of this and also have the opposite sign. So the reciprocal, also known as the multiplicative inverse, is simply going to be this number flipped. So right now this is 5 over 1. So we're going to go with 1 over 5. Okay, and it's going to be the opposite sign as well. So instead of positive 5, it would be negative. So it would be negative 1/5. And that's going to create a line that creates a 90-degree angle when they intersect. So that's the rate of change we're looking for. Now thankfully these are all in slope-intercept form. So we're looking for negative 1/5 as our m, which in this case is our first option, and these are all out. Okay, so that's that. I hope that answers questions you have on these first few here, and I'll keep your eyes peeled on the playlist, and we'll be adding more shortly. Thanks, guys.